Hello and welcome to another video. In this video we're going to be working on monotonic array. And so in this problem it says an array is monotonic if it is either monotone increasing or monotone decreasing, meaning, just to explain quickly, it has to be strictly increasing or equal or strictly decreasing or equal. So if we take a look, every value here is strictly increasing compared to the value before or equal to it, right? So 2 is greater than 1, 2 equals 2, and 3 is greater than 2. So that is true. Then for the second example, it is strictly decreasing or equal. So it is 6, 5, 4, 4. And then in the third one, it is increasing then decreasing. So 1, 3, 2, so this is false. So this problem is pretty much as easy as it gets. So let's kind of go through an example. So let's say we have, doesn't really matter, but let's just say we have like 1, 4, 5, 5, 3, 7 or something. So all we are really concerned with is to find out if at any point the array is increasing and decreasing, right? So if you take a look at these examples, the one that fails is it is decreasing at one point and increasing at another point. So all we have to do is we just have to compare all the values, and anytime there's either an increase or a decrease, we have to write that down. We're going to say like, okay, at this point it was increasing, and then we keep track of that. And then if we ever run into a decreasing value later on, then we're going to get false, right? So if we get some increasing segment, we're going to write down, okay, it was increasing. And then if we ever get a decreasing segment, then it's going to be false. Similarly, if we were into a decreasing segment, we're going to write it's decreasing. And then when we run into an increasing segment ever, we're going to return false. And when segments are equal, we don't really care, right? Like it's never going to break anything. So what we're going to do is we are going to have a variable, we'll call it tone here, and we're going to make it 0. And essentially 0 is going to mean it's not increasing or decreasing, 1 will mean increasing, and -1 will be decreasing. So let's just like go through these variables and see what happens here. And we're going to compare every variable, so you can either compare every variable to the one before it or every variable to the one after it. In my case, I'm going to start over here and just compare every variable to the one before it. So we're going to check, is this segment increasing? Yes, it is. So we're going to change this tone to 1. And now that it's 1, we're going to keep going. So now we're going to be at this value, and we're going to compare, is it increasing? Yes, it is. So if it's increasing, we check the tone, and the tone is increasing, so we're fine. Now here, we're going to look at this segment, and it's equal, so we can skip, because it's never going to break anything. Now here, it's decreasing, so we're going to check the tone, and the tone is increasing. So we had increasing, now we get decreasing. So that's a contradiction, so we're going to return false. And that's pretty much it. You literally just have a tone, and you set it whenever there's an increase or a decrease, and then whenever you run into the other one, you return false. Otherwise, you just keep going along in your array. And yeah, we can go through one more example that's a success. So let's say we have like 1, 3, 3, 5, 7, 8. So here the tone would be 0. We're going to start at the second one because we're going to compare everything to the one before. So we're going to check here is increasing. So we're going to set our tone for increasing. Now we'll be over here. They're equal, so we can skip. Never going to break anything. Now we will, so we check that. Now here we're going to check it's increasing. Is our tone increasing? Yes, it is. That's fine. No contradiction there. Now we check here, increasing. Is our tone increasing? Yes, it is. So as long as when it's increasing, as long as your tone wasn't decreasing, you're fine, right? So if it's increasing and your tone isn't decreasing, you're fine. And if it's decreasing and your tone wasn't increasing, you're fine. But whenever you have an increasing and a decreasing and you just need a variable to tell you like which one you had before, then that's what you return the error. So this is still increasing, so we're fine. And this is still increasing, so we are fine. And now finally, once we're done with the loop, we just return true. So this is as easy of a LeetCode problem as it gets. So now we can code it up. So we're going to have a tone, we're going to set it equal to 0. And now we are just going to loop through every single number in nums, and we're going to start the second number, or you can start the first number and go to the second to last number, because you need to compare every number to the one before it. Check if it's increasing or decreasing. So for I in range, we're going to say 1 length nums, and we're going to compare every number to the one before it. So if nums I minus 1, remember, we don't care about the equal case. We just need to care about increasing or decreasing. So if I minus 1 is less than nums I, that means we have increasing. So if this is increasing, we're going to check for our tone being decreasing. So if tone is decreasing, we can just return false, right? Because we have an increasing and a decreasing. Otherwise, we have two cases, right? So case 1, our tone was 0, and case 2, our tone was increasing. And either way, we can just set tone equals to 1, because if it was 1 and we make it equal to 1, that's not going to matter. So we can just set it equal to 1 as a default. So that's the increasing case. Now we have the decreasing case. So basically the opposite. So if this is greater, then if we have decreasing, we're going to check for the tone being positive. So if tone is 1, then we will do the same thing. We will just return false. Otherwise, this is the decreasing case, so we'll set our tone to -1. And finally, when we're done with the loop, we just return true because we've successfully went through everything and didn't find any contradictions. So let's take a look. Can't even do this problem without making a mistake. What else is new? I think hopefully we're good, and I think we are. Just kidding. And there we go. And you can see it's pretty efficient. As efficient as it gets, it's just going to be a one-pass. So let's talk about the time and space. So essentially, we loop through all our nums, right? And we compare every number to the one before it, so that's O of n. And we just have this tone variable, and that's it. So that's going to be O of 1. So a nice and easy problem for the day. Hopefully you enjoyed it, and if you did, please like the video and subscribe to the channel. And I will see you in the next one. Thanks for watching.